So the challenge with probiotics is they're mostly bifidus and lactobacillus because those are the ones that are somewhat oxygen tolerant, and you can grow them in a lab much more easily, so you can mass produce these things. But these are not the bacteria of an adult, right? Lactobacillus comes from the birthing canal, and bifidus came from the fecal matter. So during childbirth, the baby's exposed to both of those, and that's the beginning microbiome of the baby. But the adult gut doesn't really have bifidus or lactobacillus in it. The skin has lactobacillus, but the adult human gut, it's like 0.01% is lactobacillus and bifidus. They're not what we're meant to be using. So, yes, you can get probiotics and they're a great idea, but it's not going to repopulate your gut because that's not what your gut needs.
Hello, everyone. How are you doing? I'm Dr. Wendy Myers of MyersDetox.com. And on this podcast, we talk about everything related to heavy metal and chemical detox, and really anything related to your health that is, I find really compelling or really interesting. We talk about a lot of biohacking on this show. But really, for me, my goal is to help you to feel good. That's why you're listening to this show. That's why you want to do different protocols and take supplements. Your goal is to feel good. And I know that eludes so many of you. And so that's why I do this podcast, to help you to kind of get that information you need. So even if one show gives you that little piece of information you need to make a huge difference, that's why I do this show. So thank you so much for tuning in. Today we have Spencer Feldman on the show. He's been on many times. He's a great guest. I love him because I can just sit back and relax, and he's so brilliant. And we have another brilliant show. We're going to be talking about why probiotics don't work that well, and Spencer's top 8 tips to repair your microbiome. This is full of amazing information and amazing tips, and you want to listen to this even if you don't have gut issues or whatnot. The information in this show can dramatically improve your health, so pay attention. And today we're going to be talking about, the top 5 things that damage your gut. We'll talk about why your appendix has a backup copy of your gut microbiome. So trust me, you need your appendix. You do not want to be removing that lightly like you don't need it, like some doctors will tell you. We'll talk about how some of the broad spectrum antibiotics can wipe out 50% of your gut bacteria. It's really devastating to your health and your immunity. We'll talk about Spencer's top 8 tips to repair your gut microbiome and how to fix your gut if you have SIBO, which is small intestinal bowel overgrowth. A lot of good tips there. We'll also talk about what is gut putrefaction and why this happens. And we'll talk about how you can repopulate your gut microbiome in 12 hours. So really interesting info. And I know you guys listening to the show are concerned about detoxification. You're concerned about your heavy metal load in your body. And that's why I created a quiz called HeavyMetalsQuiz.com to help you determine your relative level of toxins in your body. So it's a super quick quiz that you can take, and afterwards you get your results, and then you also get a video series that answers all of your most frequently asked questions about detoxification. So how long does it take? What's the best way to go about it? What if I've tried detox and it doesn't work, or I just don't feel well afterwards? We talk about, the best supplements for detox, the best testing for detoxification. So check that out if you want to learn more at HeavyMetalsQuiz.com. So our guest today is Spencer Feldman. He's a multiple patent-holding inventor with more than 20 years of experience formulating and manufacturing detoxification products for doctors and their patients. His trailblazing use of suppositories to deliver ingredients that would otherwise require intravenous therapy has changed the way many doctors do detoxification. He is the owner and formulator of the Remedy Link brand of products, and now in his 50s, he lives with his partner completely off-grid on his 100-acre farm, where he spends his time tending his orchard and garden, and while continuing to design new products to help detoxify people in our ever more toxic world. You can learn more about Spencer and his work at RemedyLink.com. Spencer, thanks so much for coming on the show.
Thanks for having me, Wendy.
Yeah, so why don't we tell the audience a little bit about yourself and your background and your kind of focus on detoxification.
Sure. Like a lot of alternative practitioners, I started out not being really healthy and not getting great answers from the doctors that I was going to. And so, sort of began this journey of trying to figure out what I could do to get healthier. And I ended up finding that I really enjoyed the process of figuring out how human bodies got to a point where they couldn't fix themselves and what they needed to do to get past that point and start repairing. And so for the last 25 years, I've been making detox products, and kind of branched out from there. Started realizing that with detox came a lot of other issues. If people were toxic, they ended up having chronic fatigue. They ended up getting chronic infections. They ended up aging in a not very graceful manner. And so from that, as my entry point, I jumped into the whole functional alternative medical field. And I've been making products and equipment ever since.
Great. So we're going to talk about the microbiome today, which is super, super important. A lot of people have gut issues. It's the number one problem that people have, and there's a lot of confusion around it. And how do you heal the gut, and do probiotics work? And we're going to address a lot of different questions of that nature. But the first one is where does the microbiome come from? How was that formed, and how many gut bugs do we have in our gut? What's going on there?
Okay, so, it used to be believed that we were relatively stable, except for, maybe the mouth and the gut. It turns out we're completely colonized. So the microbiome isn't just the gut. The microbiome represents, or is referred to as, this dynamic living organization of mostly bacteria, but also bacteriophages and viruses and fungi, and if someone's unlucky, certain parasites, that all work together. Sometimes hopefully for our health, and sometimes not. They've colonized our intestines. So from the mouth all the way down to the rectum, the entire area is colonized with more and more bacteria the farther down you go. Although there's quite a bit in the gum line, but from the esophagus down, you have more and more bacteria as you go down. And we ended up, along with all other animals, getting a symbiotic relationship with bacteria and bacteriophages mostly, that would colonize our gut. And they would eat things that we couldn't eat. So, for example, in the early human experience, we've been around based on archaeological studies for about 800,000 years. And, mostly what we've been eating have been tubers and insects and fruit, seafood, wild game, nuts, seaweed, and honey, if you're lucky. And what happens is there's parts of these foods that we don't digest. They're called oligosaccharides. It's kind of sugar. So you could grossly categorize sugars into three categories. You could say they're the simple ones, like fruit sugar, that you digest really quickly. And then there's the complex ones, like carbohydrates from grains and beans, that you digest. It just takes a little more time, but you have the enzymes to do it. And then there is this class of sugars called oligosaccharides that fall right in between the two in terms of size. And we don't have the ability to digest them. We don't really have the enzymes for them, but bacteria do. So as animals are eating plants and other animals, they're ingesting these oligosaccharides that they can't eat. And then the bacteria get in their gut, and the bacteria can eat them. And then over hundreds of thousands and millions of years, we symbiotically evolve with these bacteria living inside of us because they want what's good for us, right? The longer and healthier we live, the longer they get to spend inside of our gut, being fed oligosaccharides in a dark, warm, moist, low oxygen environment, which is exactly what they want. So it's in the bacteria's best interest to keep us healthy and reproducing and living a long time. And so the microbiome is the evolution of this symbiotic relationship we have with all of these life forms living in our gut, where they want what's best for us, and they will go out of their way and have the programming to help us in a great deal. And I'll explain to you what exactly they do. But it's not just the gut. They actually colonize the entire body. There's a microbiome in the brain, the liver, the lungs. There's no part of the body that doesn't have some microbiome in it. But the part of the microbiome central, the one that runs the whole show and gives marching orders, is in the colon. And that's the one that mostly I want to address right now.
And I've read that there's 100 trillion bacteria in our body. I mean, there's more bacteria cells than human cells.
Yeah, I mean, if you add in red blood cells, then it's about equal. So about equal human cells to bacterial cells. And that's not even counting the viral cells that are living with the bacteria. And, kind of think of it this way. If you ask someone to draw a picture of a tree, they'll draw the trunk, and then the branches and the leaves, but that's half the tree, right? The other half is the roots and the bacteria living on the roots. We don't draw it because we don't see it, so we don't think about it. But, if you go to an orchard and there's a tree that's being parasitized, or it's got wilting leaves, or something's wrong with the tree, the good orchardist doesn't just look at the leaf. He looks at the root and wonders, well, what nourishment is that root not getting? So that it can't provide a healthy leaves that can resist disease. So the microbiome is the roots of our biologic or metabolic tree. And to give you a sense of some numbers, the microbiome makes something like 500,000 different metabolites, which represent, it's estimated, 40% of the compounds floating in your bloodstream. So the microbiome, weighs about 3 times more than your brain. If you take all the endocrine glands, the thyroid, the thymus, the testes, and weigh them, the microbiome has, there's more endocrine cells in the gut than there are in the rest of the body. There's more immune cells in the gut than there are floating in your bloodstream and your bone marrow. It's a significant part of our health. And let me kind of walk you through some of the things it does, because, I thought I understood the microbiome and I didn't. And I thought I understood how important it was. It's really, if you don't have the microbiome figured out, if your microbiome is off, and it is for most people, there's a glass ceiling in terms of health that we'll never get past, because it does so much for us. So let me kind of walk you through this. Where do we get it? So we're getting it from our mothers. We're passing it on during childbirth. In fact, when we're in the womb, the microbiome of the mother is guiding and managing the development of our brain neural architecture. So because the microbiome wants us to be smarter, because the smarter we are, the longer we live, the microbiome increases our intelligence by giving us very complicated brain structures. So right off the bat, before you're born, it's making you smarter. And then you could say that there's, say, 4 initiations of the microbiome. Now, the first initiation is what happens inside the womb. Our brain neural architecture is being organized. The second one happens when we're born, and the IgA from the mother's breast milk and colostrum mostly informs the immune system that the microbiome is part of the body, don't attack it. At which point the microbiome then goes on to from there, the microbiome is responsible for educating the immune system. So the microbiome is responsible for expressing self versus other. And the reason this is important is because someone who doesn't recognize what self is, well, these are people that end up with autoimmune disorders because they can't see that they're attacking their own tissue. And someone who doesn't understand what other is, they have weak immune function because they can't recognize threats coming from the outside. So the microbiome is responsible for educating the immune system on self versus other. Now, this is incredibly important for what's going on with people today in terms of the chronic diseases we're having. So let's take a look at parasites and cancer. And from my perspective, they're very similar in terms of how they work and how you could deal with them. The mammalian immune system is about 200 million years old, but parasites are 500 million years old. So they've been around for a long time, and they've learned a lot of ways about how to manipulate our immune systems and to infect us. So they can hide inside our cells. Certain types of Lyme will go inside the red blood cells. They can manipulate cytokine and interleukin signals, which is basically the communication system of our immune system. So they can make our immune system, say, stand down, not attack. But perhaps their greatest, and then there's one other thing they do. They can actually cause good bacteria in the gut to go rogue. And now the immune system has to deal with these rogue bacteria. And so they can create like distractions for our immune system to deal with. But I think the main thing they do is they disguise themselves. So like consider T. brucei, which is the parasite that causes sleeping sickness. It has over 2,000 different genes that code for the proteins on its surface. So parasites really are the masters of disguise. And when I say parasite, I don't necessarily mean a worm, a helminth. I mean something that is living in and on us in a detrimental manner versus a symbiotic way. So Blastocystis homina, there's all sorts of toxoplasmosis is a parasite, even though it's tiny and round. It's not there. It's damaging us. So these parasites, what they do is they have thousands of genes for manipulating their outer coat. So let's say they get in the body and they've got like a blue jacket and a red hat. And the immune system finally figures out, okay, blue jacket, red hat, that's danger, kill it. Okay, and it goes after all of the blue jacket and red hat bacteria. Okay, but 1% of them were kind of dormant, and they get the message, blue jacket, red hat, they were onto that. So now they have a green sweater with a red, and an orange scarf. And they come out and the immune system's like, well, I haven't seen you before. I guess you're no big deal. And so you see people who, especially with like Lyme, who will have these waves of illness, right? Their immune system will try to eventually figure out that there's a parasite bothering them. And then they'll attack it, which takes a lot of metabolic energy. And then they get better for a little bit. Then the parasite shifts from one of its thousands of coatings to another one, builds up, and then ravages the body. And then eventually the immune system figures that one out and then goes back and forth. But, it takes very little energy for the bacteria the parasite to keep shifting. And it's a lot of metabolic energy and resources used for the immune system to keep fighting. So, it's really important that our body have a very fast recognition of parasites based on how they're changing. And that's the microbiome. So remember that, human mammalian immune system, 200 million years old for mammalian immune systems. Parasites, 500 million years old. But the microbiome is 3.5 billion years old. It's been around a long time. It knows every trick in the book. And if you were to think of the immune system as like the army, then the microbiome is like the generals and the strategists figuring out what to do and giving marching orders. Now, the army can still work without a general. It just doesn't work anywhere near as well.
Yeah, I mean, that's really, that's so eloquently put, how you described all of that. I haven't quite heard it described like that before. And so we have the establishment of what the microbiome is. So how exactly is it damaged? And I've talked about this before. There's just so many different things in our environment working against our microbiome. Let's list some of those.
Sure. So right off the bat, childbirth, if the mother is stressed, she is not going to have a healthy microbiome to organize in the neural architecture of the baby's brain. We know that the mother's microbiome will shift to bifidus, which is a child's microbiome, from the other bacteria, the adult bacteria, when she's pregnant, in order to give her child the bifidus bacteria during childbirth. Now, if someone's born premature or sunny side up delivery or cesarean, they're not going to get the microbiome properly. And another part of it's obviously breast milk. Now, the mother's milk makes over 200 different oligosaccharides, those special sugars that we can't digest, that are just there for the microbiome. In fact, there's more by weight oligosaccharides in breast milk than protein, which shows you just how important evolution thinks the microbiome for the baby is, that it wants the microbiome to grow faster than the baby grows. And indeed, because if the microbiome isn't there to protect the baby, and the baby's not going to survive childhood very well. So right off we need a good childbirthing sequence with a non-stressed mother who is herself has a good microbiome, and we need to be breastfed. Now, there are three, assuming we have those, there are three additional stresses that we face as we get older. Now, the first is we're not eating the kind of primitive diet we'd have to eat in order to get these oligosaccharides we need. And we'll talk more about that in a bit. The second would be chronic exposure to toxins like glyphosates, which is an antibiotic to the gut. Artificial sugars, certain pharmaceuticals, oral hormones, these are all very damaging to the microbiome. You could call these like mass casualty events to the microbiome. When you take in artificial sugars, the microbiome thinks are oligosaccharides, eat it, and then the microbiome just gets completely screwed up. Then the worst thing one could possibly do would be certain types of antibiotics like Cipro. Now, Salmonella, which is a really nasty bacterial infection of the intestines, will knock out about 15% of the species of the gut. But Cipro could knock out 50%. So these broad spectrum antibiotics really do a number on the gut, and they also knock out the bacteria in the appendix, which is your backup, right? So if someone just got salmonella, had the runs for a few days, lost a bunch of bacteria, the appendix could reseed with a backup copy of the microbiome. But when you take these strong antibiotics and it kills the bacteria, even in the appendix, it takes a lot longer because now you have to get it from the environment. So we're now into our third generation of the discovery of pesticides and antibiotics and chemical food additives. And in every generation, the microbiome gets weaker and weaker and weaker. And we're getting to this point where we're starting to see the collapse of the microbiome, where so many keystone species have gone that the microbiome is no longer able to hang on. And then as a result, we're seeing a lot of chronic health issues. I mentioned that the microbiome is responsible for our immune system. That's just one very important, but one part of what it does. It's the regulatory agency for virtually everything in the body. The body wants to be in a homeostatic state. It wants to have blood sugar, not too high, not too low. The immune system, not too aggressive and not too weak. You want your neurotransmitters. You don't want so much dopamine that a person's manic, but not so little that they're depressed. There's so many systems that have to be managed. And this is the job of the microbiome. You would think that the brain does the managing. Not really. The brain is there for cognition, for organizing sensory and motor information, but the day-to-day, moment-by-moment, second-by-second sampling of your bloodstream for all of the different neurotransmitters, antibodies, hormones, messaging signals to determine what's going on and what needs to be balanced. That's the microbiome. So when you see people that are falling out of balance, falling out of center, and that will be the microbiome. Now, you might think, well, I don't have a gut issue, so my microbiome is fine. Surprisingly, the gut is not the best way to, gut issues are not necessarily what's going to show up in a bad microbiome. The two more common things you're going to see are going to be fatigue and brain fog. Or mood issues, because the microbiome is so important for our neurochemistry. One of the things you'll see is people they won't feel good emotionally and they'll get tired. So a good question might be, how do you know if your microbiome needs help, right? If it's not just a matter of, oh, my gut feels good, I'm fine. So, I'm sure you're aware of there's quite a few tests you can do. Have you done any of them that do the stool analysis, Wendy?
I haven't personally. It's something that I really personally haven't had any kind of health issues surrounding that. So I just haven't bothered to do any of the gut tests.
So, they're great if you can do them. They're about $500 each. So what I want to offer to listeners are a couple of ways you can kind of tell if your gut microbiome is out, kind of without going through expensive testing. Now, the first question you can ask yourself is, does your stool smell bad? Healthy microbiome creates stool that has almost no smell, maybe a little acidic from the short chain fatty acids. If it smells really bad, that's dysbiosis and putrefaction. We'll get into that in a minute. The second question is, do you need a lot of toilet paper? Now, a healthy microbiome means you wipe once and there's nothing on the toilet paper. And I know some people think that's impossible, but when your microbiome is healthy, that's what happens. Another thing you can ask yourself is, what's your transit time? Meaning, how long does it take between food being eaten and going into the toilet? Now, some people will say, well, I go to the bathroom every day, my transit time must be fine, but not necessarily. If you look between your belly button and your pelvic bone or your pubic bone, sometimes you'll see a little pooch there. That is often backed up food. So if what is coming out of you is something you ate 3 days ago, even if it comes out every day, if it's coming out 3 days later, that's an issue. That's transit time. And one of the ways you can do that is you can go get some organic blueberry extract and eat a tablespoon or two with a smoothie or whatever. Pour it on your fruit for breakfast, and then check the toilet and wait to see when your stool starts turning darker or purple. It should be 18 hours to a day, and that's pretty rare. And I'll tell you why, and I'll tell you actually how to get it. And then the last inexpensive test you can do would be to check your stool pH. And what you want to do is you want to get some. I think I have some over here. Yeah. You want to get some pH paper, right? But it's important that you get the pH paper that goes from like 6 to 8 or 6 to 10. You want a narrower range. The ones that go from 4 to 10, there's such a wide range that you're not going to be able to get the fine gradations you're looking for. So what you want your stool pH to be is 6.6 on the money, right there. If you have a stool pH at 6.6, that doesn't mean you have a perfect microbiome. But if it's not 6.6, if it's significantly higher or lower, the microbiome is definitely out. And I would say anytime you go below 6.2 or above 7.0, that's definitely something you want to address.
And can we go back to some of the things that damage the microbiome? Can you talk about smoking? Because I know that's a big issue with a lot of people. So how does that damage the microbiome?
You know, I haven't seen smoking per se. And the reason I haven't is I'm making the assumption that anybody who's looking to work in the microbiome is probably not going to be smoking because they're already trying to improve their health. But I would have no doubt that smoking or excessive alcohol drinking or any number of things will definitely stress the microbiome. I believe I remember reading that, although I couldn't quote you the numbers of which bacteria it affects specifically.
And what about antibacterial soaps?
Yeah, sure. So we live in a world where we're trying to create sterile surfaces, and that doesn't exist. There are no sterile surfaces. And if they are not sterile 30 seconds later. What we really want is a world where all the surfaces have good bacteria on them. And so, yeah, by continually washing your hands and sterilizing these surfaces, what we're pushing for evolutionarily is bacteria that can survive these sterilants. And, you know, making more and more aggressive bacteria is the wrong direction. We want to cooperate with nature and cultivate bacteria that are good for us. Right. So I want, bacteria on my cutting board that when I chop my food and I eat some of it are good for me. That is, I think, is a better way of doing it than trying to sterilize it with bleach every time and then eventually getting some bacteria on there that's just a super monster.
Yeah, I mean, that drives me nuts when people are constantly trying to sterilize their environment. I mean, those people that they are absolutely, just spending a lot of time and energy putting disinfectants and bleach and alcohol and ammonia and all kinds of other products in their home in an attempt to make it germ-free, which is, quote, clean. And it's just really kind of they're barking in the wrong direction.
Yeah, I mean, they mean well, and they're afraid, and I understand because modern media is pushing a lot of fear porn. What I would pose to them is let go of the idea that there's such a thing as clean, and realize that you're much better having a symbiotic relationship with the microscopic world than trying to kill it. So, I think we've gone over a little bit about what the microbiome is. We could talk about it for hours. What I'd like to give your listeners is 8 kind of secrets to a healthy microbiome, kind of like 8 takeaway points that they could think about and use to improve their health. So, the first thing you'd think is, if I were to, when I talk to people about the microbiome, they're like, oh yeah, sure, I take probiotics, I'm good. I'm like, all right, well, okay. So the challenge with probiotics is they're mostly bifidus and lactobacillus because those are the ones that are somewhat oxidant tolerant, and you can grow them in a lab much more easily. So you can mass produce these things. But these are not the bacteria of an adult, right? Lactobacillus comes from the birthing canal, and bifidus came from the fecal matter. So during childbirth, the baby's exposed to both of those, and that's the beginning microbiome of the baby. But the adult gut doesn't really have bifidus or lactobacillus in it. The skin has lactobacillus, but the adult human gut, it's like 0.01% is lactobacillus and bifidus. They're not what we're meant to be using. So, yes, you can get probiotics and they're a great idea, but it's not going to repopulate your gut because that's not what your gut needs. So then the question is, well, if I've knocked out some of my bacteria, and if probiotics aren't what I do, then what do I do? Since we're not yet at the point where they're being made, we're close. There are some very large gut simulators in a laboratory level where they're making things like Akkermansia and mucophilia and some other really cool bacteria. And perhaps 10 years from now, we'll get to the point where you can go and buy a lot of really good bacteria. We're not there yet. So there are 3 reserves for your good bacteria. So the first is dormant cells. Yeah. Dormant cells are the ones that are your good bacteria that just haven't been fed. So, we're always getting some oligosaccharides in our diet. These are the sugars that bacteria eat. And so it's rare, unless someone's done a really heavy and gone through some serious antibiotic use, for them to knock out all their good bacteria. Typically what happens is they just go dormant. They hibernate because there's just not enough food for them. So the easy thing for that is, if you just give the gut the oligosaccharides that it's expecting or was hoping for, then the dormant cells reproduce. And, if you think about it, a single bacteria with a doubling time of 20 minutes can go from 1 bacteria to 34 billion in 12 hours. So it doesn't take long to repopulate your gut, assuming your first reserve is in there. And for most people, it is. The second reserve, as I said before, is the appendix. I know a lot of people were told it's a vestigial organ that has no purpose. That's not actually true. It's part of the disinfectant station that is in between the small and large intestine, and we can get into SIBO if there's time for that. And it's also the backup for the bacteria. So if you've lost some, your appendix can repopulate for you. Now, the third reserve is the environment. Every person you meet, every hand you shake, every salad you eat. Microbiome is everywhere. It's in the air. It's on every surface. And that may sound disgusting, but life finds a way. So you are constantly being supplied with microbiome just by being alive. So not probiotics, it's oligosaccharides. That's the key. Feed the bacteria. Now, what happens if we can't get enough of these oligosaccharides with diet? Well, then what? All right. Well, you could, right? You could eat a primitive diet. You could eat a lot of tubers, but they have a lot of raffinose in them, and that can make most people incredibly flatulent and a lot of stomach upset. And eating a lot of insects, it's not the way that I would want to go. Eating a primitive diet, it sounds romantic, but when you actually get to it and realize that you're going to have to be chewing on tubers, 2 hours a day, it's a part-time job. So what I ended up doing is researching, if I was eating a primitive diet, what would I be eating and what kind of oligosaccharides would I be getting? And I came up with 8 key oligosaccharides. And I put them in what I thought was the ratio of what you would be getting if you were a really successful primitive hunter-gatherer. And so, product hit. There's the product. There it is. So it's a powder. And it's got those 8 oligosaccharides. And I'm going to tell you what's in them. So if you want, you can just make this stuff yourself. So what we've got is galacto-oligosaccharides. Those are the oligosaccharides you find in tubers, right? That would be like what you'd find in, jicama and, Jerusalem artichoke and that kind of thing. Xylulose oligosaccharides and pecto-oligosaccharides and fructo-oligosaccharides. And those are things you find in fruits and vegetables. And then there's a special kind of connective tissue oligosaccharide you find in wild game. You will find it in all meat, but factory-raised meat where the animals have no exercise and they get no connective tissue, you're not going to have as much in that. If you want connective tissue in normal meat that you don't hunt, assuming you don't have a relationship with some, or you can't get grass-fed animals, go for brisket. Then you have the chitin oligosaccharides, which is what you find in insects and mushrooms. Fucoidin oligosaccharides you find in certain types of seaweed. And then there's the isomalto oligosaccharides you find in honey, miso, and kimchi. And so the product we make has about 200 times more galacto-oligosaccharides than you'd find in beans and 300 times more fructo-oligosaccharides than you'd find in Brussels sprouts. So, it only takes a quarter of a teaspoon with a meal. A little goes a long way. You might say, well, gosh, do I really need to get 8 different oligosaccharides? How about, just fructo-oligosaccharide? So there's a few reasons you want a bunch of these things. One is oligosaccharides act as decoy molecules that prevent pathogenic bacteria and fungi from attaching to the gut wall. So the wider a range of oligosaccharides in your diet, the more protection your gut has against a wider range of bad bacteria. Secondly, different bacteria require different food sources. So the greater the diversity of your oligosaccharides, the greater the diversity of species in your microbiome. And third, oligosaccharides are not interchangeable. And I'll give you an example. I have a friend in her 20s, and she was 2 years into a serious and worsening health crisis. I did one of those symptom questionnaires, those 6 pages where you write every symptom you possibly have, and you try to figure out what organ system is most damaged. basically every organ system she had was at a dangerous level of dysfunction. And she was moving towards needing full-time live-in care in her 20s. I mean, her chronic fatigue was that bad. Now, what I did is I started going down the list of her symptoms, starting with the top one. So heart, took her to a top cardiologist. Heart was fine. But he said, but she has some inflammation, but her heart's fine. So then, endocrine, no, her endocrine levels, they were out of whack, but that wasn't what it was, And every time we kept trying something else, finally I got down to one of the lowest things on her symptom questionnaire, which was her gut. I'm like, all right, I mean, I didn't think we were going to turn her around, but I thought if I could help her, 20%, that would be a great win. 3 days into taking the oligosaccharides, she was happy and energetic for the first time in 2 years. And so remember when I said that you can, in 12 hours, you can regenerate your microbiome? Yeah, it can be that fast. So, she was finally recovered. We were both very happy. And so then I ran out of one of the 8 oligosaccharides in the blend that I made her. And I figured, all right, well, no big deal. She's getting 7 out of 8, right? 3 days later, she's basically collapsed again. And I said, okay. So I sourced that one oligosaccharide and I gave it to her along with the other ones. And 2 hours later, she was able to get out of bed and make herself lunch. And over the next 4 days, she got back to health. So what was the takeaway? Oligosaccharides are not interchangeable, right? Each of them, a healthy microbiome needs a mix of oligosaccharides to function properly. And the second takeaway is if you have the right materials to work with, you can retain your health really quickly. I mean, she was able to recover in 4 days, what took her 2 years to lose. So that was pretty amazing.
Well, that's absolutely incredible. I mean, you have a lot of stories like this as well. I mean, you're obviously quite brilliant and come from a depth and breadth of background of studying a lot of different modalities to help your clients.
Yeah, we were pretty pleased with it. We've had a lot of turnarounds now in things that you would not think would be related to a microbiome. And I'm at the point now where, anytime someone counsels me, right off the bat, I ask them about their microbiome. And you'd be surprised at how many people with really bad chronic health problems had a very difficult birth sequence. They were premature delivery. They got, in which they probably got some hospital-based infections in their gut they never got out. Okay, so secret number 1, take oligosaccharides, either my product or, you now know the ingredients, you can do it yourself. Keep in mind, the ratio is important because if you get the ratio wrong, you can end up pushing growing good bacteria, but to inappropriate levels. Okay, so what's the second secret? Fiber. So humans are estimated to have been here for around 200,000 years in our current form. And 190,000 of those years, we were hunter-gatherers. And in the last 10,000 years, we were farmers. And the last 100 years, modern man. Now, hunter-gatherers eat about 100 grams of fiber a day. Early farmers, about 35 grams, and modern man eats 15 grams. Now, again, I'm not going to try to eat 100 grams of fiber like a hunter-gatherer because I'd have to be eating tubers all day long. But I think 35 grams of fiber like our farmer ancestors did for 10,000 years since the dawn of agriculture is a good idea. So if 35 grams of fiber worked for the last 500 generations of humans, how do we go about getting 35 grams of fiber? Now, you might say, oh, well, I eat a lot of salad. Okay. Would you care to guess how many grams of fiber are in a cup of shredded carrots?
Not probably very much.
3. It's not. So yeah, salad's not going to do it. So the answer is beans. Beans were the first crop we ever cultivated. We cultivated them before grains. And a cup of beans will give you 17 grams of fiber. And then, that's now you're halfway there. The rest you can do with grains and fruits and vegetables. And if you make beans a staple part of your diet, you can easily get to 35 grams without having to eat salad nonstop.
Yeah, no shortage of beans here in Mexico. They're just like everywhere for a reason.
Yeah, and if they give you gas, my suggestion is to soak them and drain them a few times. And if that's still not enough, azuki beans, if you soak those, they're pretty silent. They're a silent bean. Okay, if you want to get past 35 grams, let's say you read that for every gram of, there's a ratio, I don't remember what it is, but as your fiber intake goes up, the risk of all forms of death go down. Yes, you can get past 35 grams. You're probably going to take a fiber supplement. And the problem is insoluble fiber can really irritate a damaged gut. And soluble fiber can create methane gas, which aside from flatulence is a paralytic. The methane actually paralyzes the gut and slows down transit time, which is not what you want. So, the second secret is beans. And now that takes us back to transit time. So depending on the kind of food you eat, food's going to spend around 1 to 4 hours in your stomach, 6 hours in your small intestine, and then 10 hours in the large intestine. If your transit time is less than 16 hours, you're probably not getting enough time in the gut for your food to be absorbed. And if it's more than 24 hours, and that's likely for most people, then you're going to go into a dysbiotic cycle. And remember, just because if someone says they're not constipated because they go to the bathroom every day, if what is coming out of them was something they ate 3 days ago, that's constipation. So how do you speed up transit time? Okay, don't take things like Cascara Sagrada. These are stimulants that your body gets used to, and then you can't go to the bathroom without them. Here's the trick. Consider the Hadza of Tanzania, which are arguably the most well-researched hunter-gatherers in modern day. They eat 100 grams of fiber a day, but they also do 135 minutes of vigorous exercise a day. That comes to 1.35 minutes of vigorous exercise per gram of fiber. So if you're eating a standard diet of 15 grams of fiber, that means you should, at minimum, do a 20-minute hike or a 30-minute walk once a day. And if you're going to eat 35 grams of fiber, that's about an hour walk a day. So intestinal transit and peristalsis is a very muscular activity. This is one of the reasons why exercise speeds up transit time. If you have weak muscles in your body, you're going to have weak muscles in your intestines, and they're not going to move food at appropriate speed. So cardio. Third secret is exercise, and not necessarily heavy-duty weight-bearing exercise, although any exercise is good, but more like, cardio and long walks. Now, here's another thing, another secret to transit time. You've heard not to eat at night, right? Grandmothers will say, don't eat late at night. Okay, but then they're also going to give you milk and cookies, so that doesn't make sense. Anyway, there's a special kind of peristalsis called the giant migrating contractions. There's a couple of different names for them. Migrating motor complex. And this is how the gut cleans itself of leftover debris. So what happens is this, a couple of times a day, the small intestine are supposed to squeeze everything out of them. And they won't do this as long as there's food in the stomach or in the intestines. So that means if you were to eat at 8 o'clock at night, the food's in the stomach for 4 hours, that's 12 at night. And then if it's in the small intestine for 6 hours, and let's say and then that's 6 a.m. And then if you wake up at 6:30 to go to work, you don't get that peristaltic cleanse. So the small intestine never cleans itself out. And what that means is that there's things in the small intestine that are just kind of hanging out there long term. So, and we're going to get into putrefaction in a minute. But one of the keys is don't eat, late at night. Try to have at least 13 or 14 hours between when you have dinner and when you eat breakfast. Enough time to have that cleansing cycle in the small intestine. So that's the third secret, have an early dinner and then 14 hours before breakfast. So it's really important that fiber and oligosaccharides are the only things that enter the large intestine. If you eat beyond your capacity to digest and absorb, then what happens is carbohydrates and proteins and fats spill over into the large intestine and cause problems. Fats and proteins in the large intestine stimulate the growth of a putrefying form of Clostridia, which is the same kind of bacteria that digests fat and protein in corpses and is responsible for their horrible smell. Carbohydrates, other than the oligosaccharides and fiber in the large intestine, ferment and create gas and alcohol and formaldehydes and candida. So the idea is eat enough to nourish yourself, but not so much that you spill over excess food into the large intestine and get putrefaction and dysbiosis. And this is also why transit time is so important. Let's say you do decide you go to a birthday party, or you go out to, you ate a bunch of chocolate cake, or you go to a family barbecue and you just had ribs all day long and you ate more than you could digest. All right, as long as you have that cleaning cycle, it doesn't stay in there for 5 days. So I'm not saying, never go out and feast. I'm saying, understand the price of it and understand how to deal with it. So the fourth secret is don't overeat. But then that brings you to the question, well, what happens if you don't digest even small amounts of food well, so that you're spilling over undigested food even with small amounts? So there's 3 hacks for this. One is you have to chew your food well. And if you don't have a good bite alignment, go see a good dentist. The second is you have to make sure your bile is flowing, because if not, it's going to limit fat digestion. and it'll back up in the pancreas, and it can give it alkali burns and ruins the rest of your digestion. So, we have that Glytamins product you can look at that for. And then the third is take digestive enzymes with your meals. That way, you're helping your body digest whatever it is going in and making less undigested food show up in the large intestine. Now, if your stool, breath, or body smells bad, you've probably got undigested protein spillover putrefying in the colon. And if you have gas, you probably have undigested carbohydrates spillover fermenting in the colon. And if you have gas that smells bad, you've probably got both protein and carbohydrate spillover, and that's putrefaction and fermentation. So secret number 5, chew well, keep your gallbladder healthy, and take enzymes with your meals. And I'll give you one more bonus here on this. If you are getting methane production, which is one of the types of gas, you can take like a quarter teaspoon of food grade Epsom salts a couple of times a day with water. And what that does is it'll shunt methanogenesis into acetate production. We don't have time to get into the metabolic biochemistry of it, but it'll make you make less methane. Okay, so here comes the next secret. There are 2 prebiotics, which is what oligosaccharides are, that aren't in the Panacea formula. And it's because they're really easy to and inexpensive to make. And you have to take so many of them that I wouldn't have room to put anything else in the product. So I'm going to tell you how to make those. It's retrograde starch or resistant starch and beta-glucan. Now, retrograde starches are made by cooking starchy foods like grains or beans or potatoes, and then you put them in the fridge for 4 hours. And it causes the starch to crystallize into, and it turns it basically into a time-released oligosaccharide. And this is also really great if you have blood sugar issues. If you're diabetic, pre-diabetic, but you still want to enjoy some potatoes or rice, chill them first, or noodles, put them in the fridge first for a few hours. Now, beta-glucan is not an oligosaccharide, but it is a prebiotic found in whole oats. And you can get both of these really easy. So all you have to do is cook whole grain oats, and then you put them in the fridge for 4 hours. And that's going to give you the beta-glucan and the resistant or retrograde starch. Okay. And then the last secret I want to tell you is, have a good attitude. The microbiome, it affects your moods, but moods also affect the microbiome. So, the microbiome produces, consumes, and regulates the neurochemicals that create our emotions, but our emotions also stimulate the growth of various bacteria. So the emotions of fear and anger and stress, respectively adrenaline, noradrenaline, and cortisol, they will stimulate the growth of pathological bacteria and increase the virulence of otherwise harmless good bacteria. On the other hand, oxytocin, which is the neurotransmitter that's associated with feelings of love and compassion, they support the growth of good bacteria, and good bacteria can also make oxytocin. So it's really important to cultivate a good attitude because it's going to cultivate a good microbiome. The takeaway is, before I give you the takeaway, let me tell you what happened for me personally when I started doing this. I'm in pretty good health, so there wasn't anything specific that I was hoping to get, but I had a lot of amazing things that did happen. So one of the first things I noticed was I was in front of the computer, and suddenly my reading glasses were too strong for me. And I'm like, well, that's interesting because typically eyesight gets worse with age. So the blood vessels that go to the eye, they're very, very fine. They're very small. So when people start having issues with their muscles or their blood or their blood circulation, it's usually the eyes that get it first. So my eyesight got better. Next thing is, I have a gym in my garage, and I went out and I was, working out and doing bench. And suddenly I was able to do a lot higher rep counts on the same number, on the same weight. So I had to put some more weights on there. So my physical strength went up, which I kind of plateaued. Another thing is my endurance improved. I was able to do the same exercises for a lot longer. Another thing that happened is my sense of balance improved. And I've never had a good sense of balance. I think it was from brain damage when I was in a childbirth sequence where I was mid-forceps. I was coming feet first, and they reached in and grabbed me with forceps and crushed my head. So I've never had good balance. I could never dance. And now I can, lift one foot up, put a shoe on and take it off and put it back down again. And I don't hop around, and, I could dance now for the first time in my life, which is great because, gosh, it's a lot of fun. And I've got a lot of dancing to catch up on. And then the last thing is my skin got a lot stronger. So as an example, I live off grid on a farm, and I was walking barefoot, and my foot got caught in a door, and it got jammed in such a way where I felt the top of my foot and my Achilles get jammed up. and it hurt. And, I hobbled back to my house, and I was, prepared to clean it out and irrigate it and, figure out if I needed stitches. And I'm looking at it and I'm not bleeding. Not only am I not bleeding, the skin wasn't damaged. It was red, it was irritated, but it wasn't damaged. And that was amazing to me because, a month ago, that would have just torn my skin to pieces. And then it's, Wendy, it kind of dawned on me what all these things had in common. The eyesight, the strength, the endurance, the balance. My mood was getting better. My skin got stronger. These are all things that get worse with age. So basically, in return for feeding my microbiome the oligosaccharides it needs, the microbiome was returning the favor, and it was literally making me younger.
Wow, that's amazing. I mean, that's some spectacular results just from taking these oligosaccharides. And you're making me want to eat more beans again, for sure. Because sometimes, I don't eat them because of the side effect. They can make you a little bit musical, and it's not pleasant, especially when you have a boyfriend or a significant other. But can you tell us more about your product and like where we can get it?
Okay, and remember, just soak them. Take the beans, soak them in water for 12 hours, rinse them off, soak them again for 12 hours, rinse them off. And again, the zucchini beans, you're going to have very, very little gas from those.
Yeah, I had been doing that. I had been doing that, and it's it's still, there's some issues there. But yeah, I do have some zucchini beans, so I will try that.
Those.
Yeah. I also soak them with, I cook them with kombu seaweed, and that also can help reduce the gas as well.
Absolutely. Okay, so the Panaceum product, there it is. It's basically those 8 oligosaccharides, and because oligosaccharides are sugars, it actually tastes good. So I kind of put it on top of my fruit or whatever you're cooking, or after you've cooked it. Right? I don't want to heat it per se, and it doesn't take much. It's like a quarter of a teaspoon with a meal, and good to go. I should explain, if you have SIBO, right, and you know that you can't do fructans and all the FODMAPs. Do you want to talk about SIBO? Because that's an issue we could get into.
Yeah, that's a big problem. Yes, let's discuss that.
All right. So SIBO is when you have the bacteria, and it isn't always bad bacteria, but it can be growing in the small intestine. And how does it get there? So let's talk about that process. You should have stomach acid. You should have stomach acid, and that should be disinfecting most of what gets into your gut. And then you have bile, which is also a detergent that breaks down bacteria. You have pancreatic enzymes, which are going to break down bacteria. And then you have, I think it's the FXR receptors at the ileum, which are stimulated by the bile to create natural antibiotics at the ileum. So basically, there's 2 ways bacteria can get in the small intestine, top down or bottom up. So the top down means you have to make sure you've got enough stomach acid, bile, and pancreatic enzymes in dealing with stuff coming from the top down. And you can look up online on how to test yourself for stomach acid, and just take some betaine hydrochloride if you don't have that result. Now, what about coming from the bottom up? So there's a valve called the ileocecal valve, which is sort of like midway between your belly button and the prominence of your right hip. And its job is to open up when food is coming down from the small intestine and into the large intestine, and then close again. However, there's some things can cause problems with this valve, and then food can back up from the large intestine and bring bacteria into your small intestine, and it can overgrow there. One thing is any kind of adhesions. So if someone has had any kind of abdominal surgery and it's pulling on the fascia, it can torque the ileocecal valve open. And so one thing you can do is just massage the ileocecal valve a few minutes every day. Just see if it's tender in there. The other thing is, okay, so the ileocecal valve is important. And then remember we talked about those migrating peristaltic functions. We want to make sure that there's no food just hanging out in the small intestine, right? So we need once a day to make sure while we're sleeping that there's no food in the gut, so we can squeeze all of the food out of the small intestine, so there's no bacteria and fiber and oligosaccharides and undigested food sitting there all night to grow bacteria in. Now, if somebody does have SIBO, that's a relative contraindication for Panaceum orally. They still need it. They just can't take it orally because they'll end up growing the good bacteria in the large intestine, but also growing some of the bacteria in the small intestine. So my suggestion for that, and what we do with someone, is get a 35 cc catheter tip syringe. These are just like plastic syringes about this big with a little plastic kind of a nozzle on the end. And you mix the Panaceum up with water or maybe a little bit of saline, and you take it rectally. And you lay on your back and bring your knees up, kind of let it swash around inside your gut. That way, you're getting the oligosaccharides into your gut, into your large intestine, but you're bypassing the small intestine. And that way, you're not going to overgrow the bacteria in your small intestine, but you will feed the bacteria in the large intestine. And then while you're doing that, work on a SIBO protocol. And again, work on the bile, work on the pancreatic enzymes, and work on the stomach acid, and work on the ileocecal valve, and work on getting the intestinal transit moving. So that's my SIBO addendum.
Yeah, I love that, because SIBO is such a huge issue. So many people have a lot of stressors, and even childhood development stress and things like that, and it causes them to have poor vagal nerve tone, and that cannot innervate that migrating motor complex in the small intestine. So there's an issue with that I think is a big underlying root cause of SIBO. But we need to have solutions for that. People still need to take care of their microbiome, their gut microbiome, and that's a great way to do that.
Yeah, and what I would say is, I don't think of SIBO as an all or nothing event anymore. I think of SIBO as something that everyone has to a degree, right? Because there's always, if someone just has a little bit of gas, when the gas pops open the ileocecal valve, colonic bacteria can pop up, right? So there's always going to be some reflux from the colon up to the small intestine. It's not a it's not a perfect system. So, unless you've got someone who has got an 18-hour transit time, perfect digestion, perfect ileocecal valve, there's always going to be some SIBO there. And understanding what we can do to minimize it is a really important phenomenon. And it's not hard.
Yeah, well, thank you so much for coming on the show. That was so educational. I love having you on the show because I can just kind of sit back and relax, and you just have this amazing presentation for everyone. So I really want to thank you, Spencer, for coming on the show. And I love your line of products, Remedy Link products. You can find that at remedylink.com, and there's links in the show notes as well. Amazing line of suppository detoxification products, and now this product. I love your work, and I really appreciate coming on the show to educate us.
Well, thanks for having me, and I'll get a Panacea so you can play around with it and see how you
like it. I would love that. I would love that. So everyone, I'm Dr. Wendy Myers. Thank you so much for joining the Myers Detox podcast, and it's just such a pleasure every week to interview all the world's experts on health and help to educate you and help you to make those little distinctions that you need. Any just little idea or little fact or little product or protocol that can help you really make that difference in your health. That's why I do this show, because you deserve to feel good. And so it's just my pleasure to be able to help you do that. So thanks for tuning in, and I'll talk to you guys very, very soon.
The Myers Detox Podcast is created and hosted by Wendy Myers. This podcast is for information purposes only. Statements and views expressed on this podcast are not medical advice. This podcast, including Wendy Myers and the producers, disclaim responsibility for any possible adverse effects from the use of information contained herein. Opinions of guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. Individuals on this podcast may have direct or indirect financial interest in products or services referred to herein. If you think you have a medical problem, consult a licensed physician.